automatic pronunciation assessment for Romanian. Authors are Remus-Dan Ungureanu, Stefan Rossetti, Irina Tomak, and Janika Leoste. And Remus-Dan will be presenting the paper.
Hello everybody, my name is Dan Ungureanu, and welcome to the talk about pROnounce, an automatic pronunciation assessment system for Romanian language. Stefan, Irina, and myself have been working on this for, well, as I said, for automatic pronunciation system. So let's start with a quick introduction. Learning new languages is a very complex process due to each component is involved: grammar, vocabulary, and pronunciation. As grammar is concerned, there are some similarities between languages, so that can be tackled to a certain extent. Vocabulary can be learned by oneself, but pronunciation is very challenging because there are so many differences. That the sound inventors can be different, the tones can be different, the way they blend together, and it's very difficult learning yourself. So pronunciation plays an important role. However, it's important to learn Spanish by students. Students usually it takes some practice to get it right, and having a tool that provide accurate and immediate response can increase the flexibility of the learning process. And basically, this tool can replace the teacher to a certain extent. So while exercising the pronunciation, one can also extend their vocabulary and expose themselves to new words. Automatic pronunciation assessment is a very interesting field in the research of speech, and most of them are developed starting from automatic speech recognition system, and we have done that ourselves as well. And unfortunately, we are not aware of any such systems for Romanian language, so we decided to do one for ourselves. We explored two different approaches, and we discuss them in a bit. So pronunciation evaluation is quite difficult because even as humans, we have difficulties in saying how bad the pronunciation is, and or saying what exactly is bad about it. So the same issue can be found in a assessment system. For example, from the beginning, we have asked ourselves what does bad pronunciation mean. For example, should such a system just tell if pronunciation is good or bad, or should it give it a grade? What about the level where the error occurs? There's also discussion about accent, and some languages have those, and which one is correct. Then there is a complete new discussion. What about giving back feedback? Do we focus on smaller units of speech such as a phoneme, or do we focus on the whole word? And then, for example, if we want to train an artificial intelligence model, we need some annotations. Basically saying how bad the training data is or how good it is. And then we also have to consider the problem of accent and if the training data is always 100% correct. Also, when evaluating, do we have to take into consideration the speaker's first language, or can we just look at the current recording of the target language? And then the final question is the approach we take. Is a statistical approach just fine? I mean, looking at the two recordings, the ideal one and the one that we record from the user, and compare them using some statistical methods, or do we have to be more advanced? So we called our project pROnounce, and it is basically composed of the augmented pronunciation assessment model plus the application that is built on top of that model. That is basically a smart learning application with a gamified experience. We have showcases of Expo by 2020. The two main research directions we took were basically start from an existing state-of-the-art automatic speech recognition system we have developed in the past. And then we also considered developing a new specialized model for pronunciation assessment that would be that we would start from scratch that would be smaller in size and would be basically optimized for these specific use case. The related work is quite interesting in this field because the problem of pronunciation evaluation did not attract that much research. There's no clear definition of pronunciation errors or way of measuring it. So most of the people just do a correlation between the scores the system offers and the score that is given by humans. However, there are some upsides. The fact that advanced pronunciation assessment methods have evolved together with automatic speech recognition because they are very similar in certain aspects. And we have seen an evolution from hidden Markov model-based models to deep neural networks. There is some related work about the role of the first language in pronunciation evaluation of the second language that is being currently learned. And what we found is that there is no related work for Romanian language. When it comes to our method of research, we have decided to focus exclusively on the deep neural network models because they proved to offer better results for other languages than the older methods. So, given that, the two research directions we took were start from another speech recognizer architecture from that is built on Kazi, and the other one that is the simpler architecture trained with a custom data set we have built. The first method is converting the model we have used for speech to text to a pronunciation evaluation model. We have started from Kazi, which is a well-known open source toolkit for speech recognition. It is used in many state-of-the-art architectures. The model that we have built in the past is built on the time delay neural network that takes as inputs math frequency subgroup coefficients and identity vectors. And we have updated, we have retrained this model with clear recordings because we wanted to have a very correct pronunciation recorded in a professional studio to reduce the noise, the recording noise. The evaluation process is very similar to a regular automatic speech recognition recording. Then we applied a force alignment and for get phoneme basically, and then computed the score for each phoneme. The formula for computing the score depends on probabilities for each phoneme. Basically, the score is the log likelihood, and the closer it is to 0, the better it is. The second approach we took was completely different from the first one. The single common aspect between the two is the fact that they are both based on a deep neural network. We have started from a sequence-to-sequence connection in temporal sequence model using CTC connection to temporal computation, and then iterated through different architectures until we reach one based on a transformer model. This time, we have moved from the MFCC features to use entire random spectrograms. These are much better in this case because they actually encode more information than MFCC could. So, for example, 40 integers, which represent MFCCs, actually just encode a fraction of the information that can be encoded by 32 or 264 spectrograms that we use. Also, what we changed about this is that we applied a heuristic at the final to obtain the score, and they give a mark for each recognized point. The architecture of the network is quite simple by modern standards. Basically, the input is the math spectrograms are passed through a couple of layers of convolutional layers, and the layer which are used to condense the information. Then we use the transformer to map basically the recording to the phoneme, and then at the final we obtain the probabilities for each phoneme. The score calculation uses the heuristic that considers two things. The first one is basically the probability of the phoneme, and the rank of the phoneme, which is the index in the list of phonemes that have been classified, ordered by their probability, and the heuristic assigns the score, basically good, average, or poor, and that is depending on those probabilities and ranks. We pick this probability, this possible score heuristic manually, and this is the thing that we have noticed that brings the closest result to reality. While developing this method, we needed a few other things. One is basically the data train the system, and the other one is a way to transform words to phonemes. And one easy way to do that is to use a phonetic dictionary that represents a mapping between words and their phonetic pronunciation. But that is limiting the user to the word they can use. And so we have decided to use a transform-based graph to phoneme model that takes an input, something like a word, and outputs the phoneme representation. In this case, you can see the representation in the IPA format. The other thing that was necessary for both approaches we took is data. And when data is not enough, as it happens to be in our case for the Romanian language, which happens to be a low resource language, other processes are necessary. And by other processes, I mean data mining and augmentation. And in the case of the second system, we use both of them. We have noticed that there are plenty of phonemes that are common between the English language and the Romanian language, and we decided to exploit it by selecting the words, the recordings of words in English that use only phonemes that are also available in Romanian. And the other thing we did was to use pROnounce, which is a speech augmentation method. And it masks lots of consecutive frequency channels and iterates into time after the MEL spectrogram has been obtained. So it fits very nicely in our training pipeline. Finally, building the model was just the first part of the project, and the second part was building the user interface and making it as enjoyable as possible. We have optimized our system for the best user experience and to make it suitable for people of all ages. In the end, we obtained a single-page web application that was deployed on a large touch screen, and we used the professional unidirectional microphone to record sound as clear as possible, so the score could be as accurate as possible. Presentation of the new information was made available through the help of higher native vectors, and you will actually see this in the interface. So this is what the game looks like. It was deployed to Expo Dubai 2020. On the left-hand side, you can see the list of words that we decided that would be would take the user to different levels of difficulty. And on the right-hand side, you can see the word, its phonetic representation and the short definition. There was also a video that showed the proper way of pronouncing and also was able to be played slowly. Every time a new word was recognized, it was automatically assessed by our system, and the feedback at phoneme level was provided. For example, in this case, the first phoneme S and which is S and L have been mispronounced, but all the other ones were fine. So the user got a final score of 2 out of 3 stars. A big challenge for us has been evaluating the performance of the system. The model, the data we used was not annotated in any way, and there is no very well defined metric like word error rate for speech to text system. So what we did was to assess the system from the point of view of how well it recognizes phonics, and then we manually tweaked it to observe the scores and see if they match the pronunciation. When we showed cases at Expo Dubai, at the end of the game, there was a short survey where we asked people what they thought of our game. And what we observed is that the demographic was very diverse. So we think that the survey turned out quite well. So it looks like most of the people had a very pleasant experience playing the game, and they assumed that the scoring was fair, which is good news. However, in the future, we are looking for a better way to evaluate the performance of our system. As a conclusion, during this project, we have developed two approaches for pronunciation evaluation together with the application. The models seem to be accurate after first deployment. However, we conclude that further analysis is necessary for a correct evaluation. And the big part of this further analysis will be building a data set that includes marks given by native speakers. And we are also considering improving the model by using this properly annotated data and passing it back to the model while training it. And finally, we are considering adding a layer that correlates the output with the output. I mean, the score that the system gives with the score that humans give, just to improve its accuracy and correlate our definition of mispronunciation with the definition with systems definition of mispronunciation. Thank you for listening to this presentation. If you have any questions, I'm happy to answer.
And Oscar, you have one question, and I also have one question, but your question first, please.
Okay, thank you, Janika. Thank you, Remus-Dan, for sharing with us your work, and congratulations for your work. Very interesting.
Thank you.
I was wondering here, it's a very teaser question. How would you, it's of course just your opinion, how do you think your model would react or behave in a dialect of different dialects of the same language? How do you think it would behave? Is it possible? Would you have to consider like dialect as a different language? How do you expect, with the correct training data set, of course?
Yeah, so even at this point, when we started our first model that was built on top of a speech recognition, on a speech-to-text model, we decided to retrain it and use just very clean recordings of people with no accent at all, just to make sure that the good pronunciation is the one without accent. That is a tough problem because, in my opinion, the way different dialects can be seen is are a different language to a certain extent. In Romanian language, maybe the dialects still share some similarities, but I think that between other languages, this can be even, the gap can be even bigger, and then different dialects must be considered like different languages. Okay. So just to give a short answer, I think different dialects represent different languages, but the training process can probably have like a common base and then just be fine-tuned with the data that is specific to the dialect.
Yeah, okay. Thank you, Remus. Thank you, Remus-Dan.
Thank you.
And I also have some questions. First, thank you for a really exciting presentation, because I am a language learner for years and the pronunciation is really important. So my first question was related, have you compared your pronunciation model against other language learning apps, for example, Duolingo? For example, Duolingo considers themselves as the best Romanian language learning app. This is my question. Can you
yeah.
respond on that?
So I was actually looking for papers on how Duolingo does it, and if they have a way, they have results published about how they assess the pronunciation, but unfortunately I couldn't find any. So I was thinking of building some application that would be comparing the two, but without more access to their API, basically I cannot do that.
Okay.
So, but that is still an open question. So it should be possible sometime in the future, I hope.
And maybe commenting the scores, or currently your score was good average fell. Maybe I would suggest some score type like understandable or not understandable to the native speaker, and I can comment based on my personal experience when I try to give presentation in Spanish. So I just ask some native speaker to listen to my pronunciation and what they pay attention to mostly when I read from the text. Okay, I'm honest, I can't speak really in Spanish yet, but they pay most attention to the accent. So not just the pronunciation, but the accent. How important is the accent?
Okay, so the first, as you said, about the grades. So the first time the grade was basically something for 1 to 100, but then we realized that the grade was simply not enough because, well, what is the difference between a score like 41 and 42? You don't really know, so that's why we moved to the 3 grades: the poor, very good, and average. And yes, you are correct about the different levels of where the mispronunciation can appear. It can be a prosodic, it can be a phonetic, and that is still like an open question for us. At this moment, the model doesn't recognize different types of errors. It just says that it's wrong. So in theory, the prosodic one also is taken into account, but with the model hides that all that information from us, so we don't really know like where it is happening. So without further training data, with more advanced training data that has annotations where the error occurred, we cannot really say for sure where that happens for now.
And you were talking about words, but is your model able to understand also the sentences? So everything is correct when I pronounce the whole sentence.
So at this moment, we have focused especially on a word level. So we have been testing just words, but from my brief experiments of the first model we have developed, we can actually test whole sentences. So the system would basically just output phonemes and their probabilities, and that is no different than a word or sentence.
Thank you. And let's wait for the next level. And also we have here a comment from Maria that Maria is not worried anymore so much about pronunciation. Obrigado, Maria. I didn't know was it perfect or not in Portuguese. When I visited your country a month ago, I started learning Portuguese, and before that I was thinking, oh, okay, it's so similar to Spanish. And it was so similar when I was reading the text, but after this pronunciation, to be honest, I just gave up a week ago because it really mixed up my Spanish learning. But I wasn't able to pronunciate different phonemes because I just didn't hear them with my ear. So that's the problem, whether it's the first language or the second. So yeah, I also consider it extremely interesting whether it's your native language or is it the second language? You're just not able to listen to some.
I actually been in Portugal just 2 weeks ago, and I was speaking with a native about this, and they were telling me how the same word is pronounced in the northern part of Portugal and the southern part of Portugal, and for me they sounded the same, but he insisted that there is a difference between the two, and I couldn't really comprehend which one. So yeah, I guess even in the same language there are some differences between because of the region. When you take into consideration the region where you're living in or where you were born.